Alright, I'm in sort of a rush to get this video done so you guys can have this to do your test corrections tomorrow. So you're not going to get to see any of my usual animated writing as I start and stop and talk about what I did to do this. What I did is I took snapshots of my answer key that I used to grade the test, and I'm going to talk you through each problem. So make sure you're making those corrections on your paper. And what that means basically is it might move a little bit faster than it's used to before. So if you need to pause it as a class to kind of make sure that everybody's got it written down, everybody understands it, you can ask each other questions, go ahead and pause it as many times as you need to get through it. Alright? So essentially, in question number 1, you had to take this system of equations over here. You had to take all of the coefficients of your variables and put them in this matrix over here. Okay, that's what I did there. Then you're going to multiply that by your variable matrix, which has x, y, and z in it. And that's going to be equal to the constant matrix, which is just those coefficients over here, 10, 36, and 15. Okay? When you type this into your calculator, you need to enter in this first matrix as a 3 by 3. Maybe put that in your A slot. Then you need to enter the second matrix that has numbers in it, maybe as matrix B, and that's a 3 by 1. When you multiply this out, in order to get rid of this giant 3 by 3 matrix, so that you just have your variables on the left-hand side, you multiply by the inverse of A on both sides. So what you need to type into your calculator is, and let me go ahead and write this down, you need to type in A inverse times B. So go into your matrix function, find your A inverse times B, and then hit enter, and you should get 3 numbers. You should get 2, -3, and 1, and those are your values for x, y, and z in order. If you need help entering your matrices correctly, and if you need help typing A inverse times B into your calculator, go ahead and pause and ask each other how to do that. Okay, otherwise I'm going to move on to number 2. Alright, so number 2 gave you these 4 matrices, and what I immediately did was took each of those 4 and entered them into my calculator as A, B, C, and D. Okay, right into my calculator so that I could just do all of my computations right on there. So once you've got all 4 of those entered, why don't you take a minute, pause the video, and enter all 4 of those matrices. Alright, now that you've got those entered in, you're going to type in A inverse. Hit enter. Okay, so go to your matrix button, click on enter on matrix A, and then press your X to the -1 button. Okay, and that's gonna give you that inverse. Hit enter and you should get this matrix that you see here, -3, 2, 2.5, and -1.5. Then question B asks you what is A times B. So make sure that you've entered your matrices correctly and then type A times B into your calculator. Okay? If you then, for part C over here, if you then go ahead and do it the other way and do B times A, you'll notice that you get a totally different matrix than in part B up here. Okay, so those are not the same, and we talked a little bit about how you can't always multiply in both directions, and even though these are both 2 by 2, so it'll work in both directions, those 2 matrices here and here are not equal to each other because you multiply different rows with different columns. In letter D, in order to solve this in my calculator, again, I need to multiply both sides by B inverse. Okay, if I multiply the first side by B inverse, all that's left is that X, and on the right-hand side, I get B inverse times D. Okay, so if I type in B inverse times D into my calculator, I should get this 2 by 1 matrix. That's -0.94 and -0.76. Okay, when I did A plus B for letter E down here, I didn't even bother using my calculator. I just lined up, okay, 3 plus 4 equals 7. Okay, and I did that each time. You found the things that are in the same spot in your 2 matrices, added them up, and put those into your matrix down here. Okay, you're welcome to type it in your calculator, but that's going to probably take you more time than just adding it would. And then in letter F, you know that you cannot add matrices together unless they're the same dimension. So we're not talking about multiplication here, we're talking about addition. So those need to be the same dimensions in order for that to work. All right, number 3 gave you sort of a review problem of solving this this exponential growth function. It says Mr. Anderson wants to make sure he has enough money for his daughter Samantha to go to college. When she was born, he put $5,000 in the bank at 8.5% interest. How much money will she have on her 18th birthday if the interest is compounded quarterly? So because it's compounded quarterly, I need to take this 8.5% and divide it by 4. That means that each year it's growing by 2.125%, and that is what I put in for B here. Since it's growing, it's going to be 1.02125. And then my starting value, this A, is 5,000. I don't have an asymptote in this problem, so I can just put my starting value right there. And then when I'm figuring out how much money she has at age 18, I need to take 18 years, and since it's quarterly, she gets it 4 times a year. So it's really going to be compounded 72 times. And then when I type that into my calculator, the answer is just she will have $22,723.70. Now, if you forgot to solve this as a quarterly interest, okay, the answer that you probably got was this orange one over here, that $1,777,915.65. So if this is the answer you got, go back and fix it so that you're compounding with the quarterly interest, not the annual interest. All right. In part 2, we wanted to know at what point is she going to have $50,000 if this is her bank account. So I'm going to use that same equation, and now I don't know how many years it's going to take, so I'm going to leave that x in there, but it still has to say 4x. Some of you ran into problems for forgetting that 4x. And then go ahead and solve it. So you're going to divide both sides by 5,000. That's how I got this 10. Then you're going to take this equation and put it into logarithmic form, which is right here. Okay? And then you divide log of 10 divided by log of 1.02125. And then go ahead and divide that number by 4. Okay? So you're going to do this part and then take that number, divide by 4. And that'll give you x is 27.38 years. Moving on to the next one, we're talking about flowers. Now you had to set up this cost matrix vertically like this. Okay, if you set it up horizontally, when you multiply, it's not going to mean anything. Okay, so I need to take these two and I need to set this one up vertically like so. So lilies, roses, daisies, and their cost going down like that. Okay, then I'm going to multiply this 3 by 3 matrix, and so this is a 3 by 3 with this 3 by 1 matrix, so I can do that. And what I get is 5.1 on the top, and I did a little calculator error myself when I did this, but I got 5.1 on the top, 435 in the middle, and 750 on the bottom. Okay, and what that represents is the cost of each bouquet to make. Okay, so I took the number of flowers in each one, multiplied it by the cost of each flower, and so this is each going to tell me what it cost me to make each bouquet. Most of you totally nailed that one. Okay. Last but not least, we're dealing with the Roadrunner and Wile E. Coyote. Okay, so let's see if I can, I don't think I can zoom in on this, but we'll do our best. So I tried to, here we go, we can zoom in a little bit. Make a picture of this data. So I know there's going to be an asymptote at 3. Excuse me. There's going to be an asymptote at 3. And I have 2 points. One at 200 and one at 103. So I took that information and I went ahead and I wrote this equation and this equation. So that's where you need to start. 200 equals AB squared plus 3 and 103 equals AB cubed plus 3. Okay, on both of those equations in the next step, I subtracted 3. Okay, so I subtracted 3, I got 197 equals AB squared, and 100 equals AB cubed. Okay, then I'm working down on the left over here. So from there, I went and solved this equation for A, and then I plugged that back in up here. So I put in that 197 over B squared in for A in this equation. Okay, and so I ended up with this over here, and this is what I need to solve. So I need to look at this B cubed over B squared, and B cubed divided by B squared is just B. Okay, so I get 100 equals 197 times b. Go ahead and divide both sides by 197, and you get that b equals 0.508. Okay, then you need to find a place to plug this in. So I went ahead and plugged it in this a equals 197 over b squared. So I plugged that 0.508 in for b and solved for a. Okay, and got 763.38. Then I just plugged all that information into my equation, and the biggest mistake I saw, if you made it to this point correctly, was you forgot this plus 3. Do not forget that plus 3. That's really important that you have that asymptote on there. And it's going to be really important in this problem right here, where we're trying to figure out if the Roadrunner is 3.5 feet tall, how long will it take for the missile to be low enough to hit him? So I put in 3.5 for my y, okay, and I want to know how long it's going to take to get there. So I'm going to go ahead and subtract 3, and I get 0.5 equals 763.38 times 0.508 to the x power. And then I'm going to divide both sides by 763.38, and this is what I get. Then I'm going to change that into logarithm form, and I get log base 0.508 of 0.000655 equals x. So type that into your calculator, and you should get x equals 10.8. Okay, now of course, since we can only keep the Roadrunner in our sights for 10 seconds, we went over that 10 seconds, and so if you've ever watched Looney Tunes, which probably you haven't, because probably you're too young, which makes me sad, but if you've ever watched Looney Tunes, Wile E. Coyote never catches the Roadrunner. That's the whole idea of it. Okay, so it makes sense that our problem is no different. He's not going to catch him. So I hope that was helpful enough for you to make your corrections, and now you're going to move on with the rest of the classwork for today.